So 6.4 vectors on the dot product. So the dot product, I'm going to let U be x1, y1. I'm going to let V be x2, y2. The dot product is going to be denoted by U dot V. Literally, there's a dot in the middle. Okay? And it's called dot product. What is it that we're doing? We're going to multiply x1 times x2 plus y1 times y2. And we're going to get a number. The answer is not a vector. The answer is a number. Scalar, yeah? Okay, example 1 have A and B. So we're going to do 4, 5, dot 2, 3. So x's with x's. What's my first x value? 4. So 4 times what? 2 plus 5 times 3. So 4 times 2, 8. 5 times 3, 15 plus 8, 23. So the answer is a number. Next one, 2 times 1 plus negative 1 times 2. So we got 2 times, 2. What do I have when I have plus and then negative? Minus 2. So 2 minus 2? 0. So that's what I was saying earlier. When you multiply a dot product, you can either get a number, it could be positive, it could be negative, or it can even be 0. Our next part again is the angle between two vectors, and it's cosine of theta equals u dot v over the magnitude of u times the magnitude of v. Do you guys remember from yesterday what's the magnitude? How do I get a magnitude? In this case, they're in the initial side or initial point is in the origin. So all we had to do is square the x value, square the y value, and add them. Okay. So let's break it down. I need the dot product, and then I need their individual magnitude. So let's do u dot v. That's the first thing I want to do. So 4 times 3, and then 3 times 5. So you said 12, and 3 times 5? 15 plus 12? 27. What's the magnitude of u? I'm going to do 4 squared plus 3 squared. What's 4 squared? And 3 squared? 16 plus 9? 25. Square root of 25? 5. Magnitude of v. I got 3 squared plus 5 squared. So it will be 9 plus 25. What's 9 plus 25? 34? Is the square root of 34 a perfect square? No, it's not. Leave it. You guys need me to pause right there? Okay, so to find angle, how do I solve for the angle? I have cosine theta. How do I solve for theta? Inverse. I'm going to do cosine inverse. What is u dot v? What do we get? We got 27. What was the magnitude of u? What was the magnitude of v? And then we enter that in our calculators to get the angle. Careful in WebAssign. WebAssign is going to ask you questions in radians and questions in degrees. So make sure you know which one is asking you for radians or degrees. Okay, in degrees, the answer is 22.16. Can we continue with our next thing? Yeah. Okay, so a different form for a dot product will be magnitude of u times magnitude of v times cosine of theta. And we'll use that in a little bit in our next problem. What we're doing right now, orthogonal means perpendicular. Orthogonal means perpendicular. That means it's a 90-degree angle. U dot v equals 0. That means your dot product is 0 if and only if u and v are orthogonal. So I'm going to ask you some questions and web assignment also on the test. I'm going to give you two vectors and I'm going to ask you if they're orthogonal or not. What do? You do the dot product. Okay, you do the dot product. If the dot product is 0, they are orthogonal. If the dot product is not 0, they're not orthogonal. They both had to be, the dot product needs to be equal to 0. Okay? Question? No? Let's do the example. Okay, so now we're going into projection u onto v. Okay, so I have a vector u. I'm going to have a vector u that can be written as the sum of two orthogonal vectors. That is called the projection of u onto v. And this is the formula. We're going to do the dot product of u and v over v squared, magnitude of v squared. This is v. So in order to find the projection of v onto u, I just need to follow the formula. Okay? So again, I gotta do the dot product. What is 3 times 6? 3 times 6? How were you telling me the answer? Because negative 5 times 2? And you were telling me the answer is. I only need the magnitude of v. That means I gotta do 6 squared plus 2 squared. What is 6 squared? 2 squared? 36 plus 4? 40. Does it have a perfect square? 40? Oh, it doesn't have a perfect square. Okay, so then W1 is going to be the projection of V onto U. The dot product was 8. This is my V. It looks like a square root, but it's a V. Oh, a projection, it's a subscript, is a V. And then the U, it's on the same level as the projection. And so we have the square root of 40. But this is what? Squared. So this simplifies too. Can I simplify my fraction? 8 over 40? By 8, right? What would that be? 1 over 5. Okay. So that was W1. To find W2, I gotta do U minus W1. Okay, give me one quick second. Okay, right here on the projection, we have that's a scalar is a number, which is our 1/5. But we need to multiply times vector v. Okay, and now I need to vector v. I need to multiply vector v. So I'm going to do 1/5 vector v. In my case, was 6, 2. So then my W1 would just be 6 over 5, comma 2 over 5. I'm distributing the 1/5 into B. We're almost done with our notes. So W2, I gotta do U minus W. I'm gonna do the x's. What are my x's? What's my x for my U? Is 3. So we're going to do 3 minus 6 over 5, comma, -5 is my y, minus 2 over 5. What will be my common denominator? Because right here, to find W2, we're going to do U minus W1. So we're going to do the x of U minus the x of W1. And then I'm going to do the y value, -5, minus W1, which is 2/5. Common denominator is 5. So how do I convert that into 5? This is W2. It's a subscript, W2. Equals. Oh, right here, it's an equal sign. So 15 over 5 minus 6 over 5. -25 over 5 minus 2 over 5. So then W2 equals 15 minus 6, 9/5. -25 minus 2. Okay, so last thing we're doing is work. Work, again, is the magnitude of the force times the distance, but either you're pulling it at an angle, it's cosine times the force times the distance. So to close a sliding barn door, a person pulls a rope with a constant force of 50 pounds at a constant angle of 60 degrees. Find the work done in the moving barn door 12 feet to its closed position. So what's the force? What do they give me as my force? And what's the angle that we're moving? And then 50 pounds. And how much is it moving? 12 feet. So all we had to do is cosine of 60 degrees times 50 times 12, because they gave me all the components. All I had to do is plug this into my calculator. So the work done to close this door was 300. And we're done for today.